Hello, this is Haitham Ali. Flexible takeoff. Flexible takeoff. We hear always about a flex takeoff using engine power. Engine power flex takeoff. In that case, the pilot, through the multi-purpose control display unit or control display unit, enter at an ambient temperature greater than the outside ambient temperature. In that case, the engine will calculate a maximum of RPM, EBR or N1 mode less than the normal. A lower limiting EBR and N1 will come. Why the pilot do that? To increase the life of the engine. To increase engine life. To reduce engine wear. Okay, everybody? To reduce the heat of the gas temperature, EGT, on the turbine. So the turbine can live longer. So flexible takeoff mode is one of the very popular modes and is used by the pilot to increase engine life. So, why the pilot may do that? In a case, maybe we can take off, okay, without the need of the full power of the engine. Maybe it is a ferry flight. Only the pilots and the cabin crew on board, no passenger, no payload. Why we use the full power of the engine that may take off with a full load on the aeroplane? Okay, everybody? So in situation where takeoff can be executed without needing full engine power, in that case the pilot may enter an outside air temperature more than the existing one to have a flexible takeoff mode. Flexible takeoff. For example, with a light takeoff weight from a long runway, then reduced takeoff power may be used. Okay, everybody? The flexible takeoff mode or flex takeoff help reduce engine wear and it also increase engine life. How the pilot may perform the flexible takeoff? The most basic way to achieve the reduced thrust is to manually set a lower RPM setting, low N1 or low EBR, lower N1 or lower EBR. And to achieve a reduced power setting with the auto throttle, a temperature that is higher than the ambient airfield temperature can be set on the MCDU. This causes the thrust computation system to calculate a lower limiting EBR or N1. EBR or N1, everybody, is the primary engine control parameters. Some engine manufacturer use EBR as the main engine control parameter, main engine thrust control parameter, and an indication for the engine performance. And some other manufacturer use N1. Like for example in the A320, V2500 or International Aero Engine use EBR. But on the other side, the CFM International, CFM 56 use N1. So, this causes the thrust computation system to calculate a lower limiting EBR or N1, thereby producing reduced power for takeoff. So always everybody, in any case that we don't need the full engine power, we may take off in a flexible takeoff mode. And if you will take off with auto thrust engaged, you must enter to the auto thrust, you must give the auto thrust an outside air temperature more than the really outside air temperature. So the auto thrust will compute a lower limiting for EBR and N1. So the gas temperature will be less. Okay, everybody? So the engine power will be less. Maybe you will take off from a very long runway with a less load or a lower load. No payload, no passenger. It is a ferry flight. All these cases you will need or you need to accomplish a flexible takeoff mode. Okay, everybody? For example, in Airbus, we have detent in the forward part of the forward segment of the throttle lever. Idle climb, maximum continuous thrust, or flex takeoff, and the toga. So flex takeoff is less engine power than toga mode. Toga is takeoff or go around. Flex is a reduced engine power. So if you perform the takeoff with a manual thrust, you put the throttle lever on the MCT or flex takeoff. And also if you will engage the auto thrust, you put a temperature more than or higher than the outside air temperature, and you put the lever on the MCT, okay, or flex takeoff, to allow the engine not to produce the full engine power. So again, the advantage of the flex takeoff mode, this help reduce engine wear, also increase engine life, increase turbine life, reduce EGT, so that the turbine will not be possessed to a very high temperature like normal case in full engine power. Okay, everybody. Thank you always for your good listening. This was my aviation nuggets for today, produced by Haytham Ali from Cairo, Egypt. Thank you for your good listening, and always fly safely and maintain your aircraft very safely. And I will meet you again very soon. Bye-bye.